Hi guys, myself Angit. In this video shows you the problem on LeetCode. Find first and last position of element in a sorted array. So given an array of integers nums sorted in non-decreasing order, find the starting and ending position of the given target value. So they have said they are given a target value and we have to find the very first occurrence of that position of the very first occurrence of the element and last occurrence of the element. And since the array is in sorted format, though they will be in together position only. That means if the array is like 1 comma 2 comma 3 comma 3 comma 3, then 4. So we need to find first and last occurrence of 3. Let's say target equal to 3. So in such case, this is not equal to 3, this is not equal to 3, yeah, this is equal to 3. So this is the first occurrence. Then coming to the last occurrence means this 3. So it's like 0, 0, 1, 2, 3, 4, 5. So first occurrence will be at third position and last occurrence will be at the fourth position. 0, 1, 2. So this is the second position. So how do we solve the problem? So what we can do is without so when it comes to the sorted array, they said it's a sorted array. Usually we use binary search approach, right? So let's say first without binary search, just a linear search. So we start from the very starting position. So next, is it equal to 3? No. Next, move ahead. Is it equal to 3? No. Is it equal to 3? Yes. So let's have a very first equal to 0, okay, or minus 1. So if first was minus 1 and we encounter target equal, the given element is equal to target, then replace it first by the position, that is 2. Then last also will be initialized to minus 1. So last also will replace it by 2. Next, move ahead. Is it equal to 3? Yes. So that position will be 3. Now increment only last, not first, because first is not minus 1 now. If it is only minus 1, then only increment it to the position. Then move ahead. Yeah, it is equal to 3, so increment last by 4. So this is the first and this is the last occurrence of the element in the array. So if I need to write a code for I equal to 0 to n, you have to check whether array of I is equal to target. So if array of I equal to target, then check if first is equal to minus 1. What we need to do, first will be equal to the I value, and and irrespective of first equal to minus 1, last will be always incremented to I value if it is equal to target. So this is the code, pseudo code. So but this takes big O of n as a time complexity because we have to iterate from start till the end of the array in the worst case. So the better approach, we know that binary search. So how do we apply the binary search approach to this problem? We will look into that now. Okay, now we will first look for the finding. We cannot find first and last together in a single binary search iteration. So we need to do it twice. So in the first iteration, we'll look for the first now. We'll not last will be looked into the next part. So as we know, we need to have a pointer, one pointing to the beginning and the pointing to the end. So let this be low and here it be high. So we have to find mid and I'll write the position 0, 1, 2, 3, 4, 5. So 0 plus 5 by 2 will be 2.5. So approximately it's 2. So mid is pointing at the position 2 now. Now you need to check whether this is equal to target value. Yes, it is equal to target value, right? Target is 3. So this is equal to target value. 3 equal to 3. So if array of mid equal to target value, then what we need to do? We have to initialize first equal to mid now. But one thing we need to notice is, let's say instead of 2, this is 3, okay? So that we can handle all the cases. So, but the first occurrence is not at the position 2, it is at the position 1. But how do we get the position 1? Since we need the first occurrence, do we need to look the elements after mid now? No, right? Only the elements before mid is required because we need the very first occurrence. That's why what we will do is, we will assign high equal to mid minus 1. This is what we need to do. So this is fine now. So we need to do high will be equal to mid minus 1. So high is pointing here. So we have to newly calculate mid now. Mid will be equal to 0 plus 1 by 2, that will point to 1, 0th position. So this is mid now. So is it equal to target value? No. So what we need to do? In this case, array of I is less than array of mid is less than the target value. So the value which we need is present after mid. So that's why what we need to do, we will make low equal to mid plus 1. Low will be equal to mid plus 1. So low will point to here. So once you have low high both pointing to same number, mid will be the same itself because 1 plus 1 by 2 will be 1 only. Now you have mid pointing to here. Now check whether is it equal to target. Yes, it is equal to target. So that's why we will have first equal to mid value, that is 1 position, and then you do high equal to mid minus 1 to check whether there is there any further occurrence of 3 before to this value, this position, and that causes high to here, low will be here, and low and high across until low lesser than equal to high only we do this. So once low crosses the high position, you stop the loop. So basically, we calculate the mid, then check where array of mid is equal to target. If it is equal to target, then what we do? So if it is equal to target, then first will be equal to mid value, and high will be equal to mid minus 1 value. Because to check is there any occurrences of 3 previous to this position. After is not required now because we are finding the first. Otherwise, what if array of mid is less than target? Then normal, so low will be equal to mid plus 1 we do. And another case will be array of mid what is greater than target. So that will be last else part. So in such case, high will be equal to mid minus 1. And this is for first. Same case for last, only with the slight changes we need to do. So if it, array of mid equal to target, so what you need to do in this case? So last will be equal to mid v as it. So next, this here comes the twist. So here if we have the array like this, and this is low, and this is high, and mid is pointing over here. So is this equal to target? Yes, it is equal to target. So in such case, we need the last occurrence, right? So you have to check after mid now. Before mid is not required. Once you get the target value, you have to check for the after mid positions. So what you do, low equal to mid plus 1 in this case we do. So if it is first, then we do high equal to mid minus 1. But if we need last, we do low equal to mid plus 1. Then everything else remains the same. If array of mid is less than target, then low equal to mid plus 1 we do. If it is greater than target, then high equal to mid minus 1. That is as usual. So once you get the target, which position you have to take up, which value you need to increment. That is what we need to look after. If it is last, then low will be incremented to mid plus 1. So if it is first, then high will be incremented to mid minus 1. Everything else remains the same. Okay. So we will have a function. It's a private and its return type is int. Let's name it as first. So it has array nums, comma int target. Similarly, other function for last as well. So private int last. So even that has a array nums and target value. And here we'll have int first index equal to, we are calling the first function nums comma target. Similarly, int second index equal to last. When last index we will write it as, okay, last index equal to, we call the last function nums comma target. So at last we need to return this as new int array, as an array. So first index comma last index, and now we will write the function here. So we'll have int n equal to nums dot length, then int low equal to 0, int high will be equal to n minus 1, and int first let's assign it to -1. So that is one thing which you need to look after also. If you don't anyway, if you don't find the target, then just you need to return -1 -1. Okay. Now while low lesser than or equal to high, we have to calculate the mid first. So mid will equal to low plus high by 2. So after calculating the mid, so next thing what we need to do is we have to check if nums of mid is equal to target. If so, then first will be equal to mid position and high will be mid minus 1. Else if whatever nums of mid is less than target, in such case low will be equal to mid plus 1. Okay, here one bracket. Else part will be, what if nums of mid is greater than target, then we have to reassign high equal to mid minus 1, and at last return the first. So same code with slight changes we have to do for the last. Just copy this and paste it over here. So instead of first we have to take last and return last. Here also last. Then okay, here instead of this we have to make low equal to mid plus 1. Yeah, that's it. So we shall run this. Okay, so Java code is accepted. So we'll see how do we make it for C++. So C++ also it remains the same. I'll copy the two functions first entirely, and yeah, here I would paste it. Okay, we have two functions now, and this is not required the return type. Yeah, so you have these two functions, and here you have to change instead of length it should be size. Then okay, here also instead of length it should be size, and this should be vector integer type. So okay, Then at last you have to call the function. So that I'll copy from the Java code. So copy this and paste it over here. And here this is not required. Just the pair is fine. Directly we can return them. We will run the C++ code as well. Okay. Um. Yeah. Here. Okay. By mistakenly, I have pasted the code here. This should be deleted. Yeah. Now this looks fine. Okay. It's accepted. We'll submit any one of the codes now. Okay, successfully submitted. If you understood the concept, please to like the video and subscribe to the channel. We'll come up with other next session. Until then, keep learning. Thank you.